Hello everyone. At this part of tutorial we will add a Niagara system that will appear every time we hit a tree, like this. And also we will add a logic to make tree fall right after we have cut it out. Like this. So let's start. Hello everyone, this is the second part of tutorial videos about tree cutting, and today we're gonna add some Niagara system that will be shown every time that we hit a tree. So let's navigate to a folder where we have our blueprint of a tree and create a new Niagara system. We're gonna create it from a directional burst. So select new system from selected emitter, then select the directional burst and finish. Let's call it ns chop chop particles, and let's open it up. This is how it looks like right now. But we don't want to spawn just sprites. I want to spawn some meshes, so I've opened the Quixel bridge and found this mesh. It's called tree debris, and you may select any mesh you want. I'm gonna select this one, and I think that I will download it. I don't know, I think maybe medium quality is fine, so I'm gonna download this one mesh in medium quality. And I'm gonna click add second time, so it will navigate me to a folder where it is located. So on medium quality it has 100, no, it has 1000 triangles. Well, that's a lot. By the way, I think LOD 1 is fine, so I will set minimum LOD to 1 and save it. Well, also, one more thing that I want to do, I want it to look a little bit brighter. So what I'm gonna do, I'm gonna create a separate material for this debris. So I'm gonna call it M chop debris. Also, I'm gonna rename static mesh to SM chop debris. Well, let's open chop debris material and select all the textures that Quixel gives us and drag them right into material. Well, normal goes into normal, R of RDP texture goes into ambient occlusion, G goes to roughness, and B remains empty. Well, now what about base color? What we're gonna do, I'm just gonna multiply it by some color. I'm gonna create a constant 3 vector here and plug multiply to a base color. This is how it's gonna look like. It's dark, and what I'm gonna do, I'm gonna change the color so that it will be a little bit brighter. Maybe like this. So now I'm gonna apply this material that I've created, chop debris, onto my chop debris static mesh. So I open static mesh and applying it. Well, maybe I should change a color a little bit more. Well, that should be fine, I think. Yes, okay. Now let's open our Niagara system back, and here we have an emitter. And this is a sprite render emitter, so we don't need to render a sprite, so we can just delete it and add a new renderer called mesh renderer. Here we have to select a mesh that we want to render, and it's gonna be SM chop debris, like this. and save it. Well, I'm trying to zoom in a little bit. Okay. Well, that looks... Where is start location? Let's disable gravity right now and the drag right now. And I have to move the camera somehow to that we will be able to see it. Well, that's okay. So now let's open an initialized particle. And what do we have here? We have a lifetime, and I think that lifetime is normal. Sprite attributes doesn't affect the mesh, so mesh scale mode. Let's make it random uniform. It's gonna be from 1 to 2. Then mesh render, okay, that's unneeded. Well, that's fine. Now let's open mesh render, and I think that we have to change facing mode here, and facing mode, well, maybe default is also fine. So we have to change the rotation of our particles, and no, sprite attributes should not affect it. Maybe I'm wrong. For example, random. Pause it a little to check. Yes, this doesn't affect, so sprite attributes doesn't affect it in any way. And what do we have to do? We have to be able to change the rotation of our particles here, because now the rotation follows the velocity. But, and also our velocity in cone is too horizontal. I think that so they don't spread too much vertically. Well, let's select net velocity and change cone angle from 50 to something like 70. Well, that looks a little bit more realistic. Well, I don't remember how can we change. Maybe we can just add rotation velocity. Tell mesh orientation. Well, here we can add an initial mesh orientation, and now our mesh orientation is randomized, so it looks like this. Also, to test it, let's add them here closer to a tree so that we will be able to see whether their scale, their size, and an amount of particles is fine. So they play only once, and if you want to play them one more time, disable auto activate and enable it again. I think that scaling is too big, so I'm gonna decrease scaling from 1 to 2 to 0.5 to 0.75. Also, I think that a burst amount is too big, so 75 is too big. To change it, select spawn burst in emitter update category and change spawn count. I'm gonna change it to 40. Well, now what we're gonna do now? We don't need scales precise by speed. Solve forces is velocity, scale color also unneeded. Solve forces and velocity, yes, it is needed. Well, where is it? Okay, now we have to add the gravity. So let's enable gravity force back, and we can change gravity if it will not fit our needs. So let's auto activate it again. I think that maybe speed is too big for them. So let's select the velocity, and here we have a velocity speed. It's from 250 by default to 150. It's too big distribution is for me, so I'm gonna leave it to at 250 to 400 maybe, and test it again. Well, that looks fine, I think. Now let's open our blueprint of a tree. And here we're gonna, on event chop, on every chop, we're gonna show these particles, but we don't want to spawn an emitter for every chop. So I think that it will be fine if a tree will have this Niagara system. So let's add this Niagara system here. Let's add a new Niagara particle system and call it chop particles. And select a needed Niagara system. Here it is. Move it to a correct side. It's gonna be at the middle of a tree. So 0 and 0, only that is changed. Well, looks like its Y should be here. Yeah, a pivot, an origin of a tree seems to be a little bit incorrect. So align your Niagara system right with the center of a tree. And disable auto activate. Well, what we're gonna do now, we're gonna activate these chop particles every time we chop a tree. So let's get chop particles and call activate function with reset. That's the first one. Next, let's check whether our chop particles has a loop. So loop behavior should be set in emitter state to once. So it will play only one time. Now it should work. So let's try it. Okay, it works, but looks like their speed is too big, and as you can mention, they only have one direction, but I want them to fly in a direction opposite to hit direction. Like if we made a hit with our axe from a south, then the particles should fly on a south way. So let's decrease the speed at first and make it from 100 to 150. And to know where to rotate our particles, we have to know where was a hit. So our event chop should have an input with not only damage but with something else. So let's open a blueprint interface called BPI choppable. Well, select a chop function and add a new input. Well, why can't I add a new input? Oh, I didn't see a plus button here, so select plus button, and what we're gonna add here, we're gonna add some hit location maybe. Yeah, so let's add let's try with the hit location. It's gonna be a vector. Well, now our BP3 will receive a hit location, but we need to provide it somehow. So let's open our character where we have or it was an axe. I think that it was an axe. So let's open our instrument, and here at place where we are handling an overlap, we we should also provide function chop with a hit location. So what's going to be hit location? Hit location is going to be a location of this box. So it's very simple. We just get in this box and get in its world location. Not relative, but world. Compile, save, back to a tree. Well, now we have to rotate our Niagara system so that it will face a hit location. So now let's select our chop particles and get their world location. And here we have to get a rotation that is needed to face a hit location. So we have a function called facing get free. Well, how it is called? A look at find look at rotation. Maybe find. Yeah, it's called find look at rotation, and we have to provide from where to where. We're gonna find the look from particles current location, world location, to a hit location, like this. And this is gonna be a new rotation of our particles. So let's get your particles and set scale, set, set world rotation. We're setting world rotation, and this is gonna be this one. Compile and save. And also I have made some tests, and my material by default has a strength of 0.6, so I will make it 0. And let's try it now. Well, I didn't see them. Okay. The problem is that they are also rotated by they should be only rotated by z-axis. So let's open our BP3, and we should not set this rotation. So X and Y should stay the same. And well, let's continue. I had some issues, so now let's start. And first thing that we have to do is at last time we found the look at rotation, and now we will have to set world rotation of our particles. But we don't need to set a roll and pitch. Roll and pitch should stay 0 because we don't want to rotate our particles in the vertical axis. We only want it to rotate horizontally, so we have to change yaw only. Well, also one thing that I have mentioned is that a gravity of particles is too high. So let's open a Niagara system, select gravity force and decrease it from minus 980 to minus 500, for example. You may change all these values as you want. Okay, now let's test it out. Okay, now they fly to us, but sometimes their direction is wrong. And that happens because in my instrument, in our instrument, we're getting a world location of a current world location of a box. But that should be an incorrect because when an overlap event is called, a box location can be bad for us. So I think that it will be fine if we will get a character location. So let's get player character and get actor location and plug it into a hit location of a chop function. Well, let's test it out now, and I think that particles now should always fly to our character. And yes, it works, but they are not seen very good, so they should be rotated a little bit to the right. So their rotation should be decreased by some angle. So here we're setting a new rotation yaw, and let's decrease it by, for example, minus 10 degrees and plug it here. So they will fly a little bit to the right. Well, that looks much better, I think. But I think that it can be decreased. For example, minus 20. Okay. And now let's test it again. Well, great. I'm gonna move chop particles here a little bit higher. And I'm gonna change Niagara system a little bit more. So what I want to do, I want to add a cone velocity. I want to increase an angle. I want to increase an angle from 70 to 85, almost 90 degrees. And the speed is gonna be from 130 to 180. Okay, and I think that now it should fit my needs. You may change these variables as you wish. Okay, great. Now I'm gonna decrease a burst spawn count from 40 to 30. Well, that's it with the chop particles. Well, let's continue. I made a little pause to fix my material, and the problem was that I accidentally used the wrong material for my tree. And what do we have now? Now we can cut a tree, and its trunk will be scaled using world position offset, and some particles are spawned every hit. Well, one thing is left, and it's finally cutting. So our tree is not falling when it is cutted. So let's do it. We can have few ways of how it can be done. An easiest way is just set simulate physics to our tree. It's an easiest, simplest way. But in my case, I want uh, only trunk to fall, and a stump here will stay remained. But the problem is that I don't have a stump and I don't have a trunk. And normally you should do it using a Blender or using a Maya or some other 3D modeling software, but I don't know how to use it. I'm not a 3D designer, and that's why I'm gonna use a modeling tool in Unreal Engine. So the first thing I wanna do is I'm gonna duplicate this tree. So I'm using this tree, I'm gonna duplicate it. Here it is, and move it into my folder of tree cutting. Open it and rename it to SM Stump, for example. Duplicate it and name another one SM Trunk. Well, now let's move them onto our scene. And let's copy that value of first one and paste it to a second one, like this. So they are at the same Z location. Well, now let's select left one, for example, is going to be our stump, and open a modeling tool. Here on the model section we have a plane cut. Select it, and now we can move a plane to cut our mesh. For example, I think that this one will be fine. Okay, before we cut, let's copy that location of this plane. So just copy it and tap accept. Here it is. Now next let's select a second model and select a plane cut and paste that value. Here it is. And click button flip plane. So it will flip and it will cut us only a top part of a tree. And tap accept. Now, as you can already maybe mentioned, when I'm moving far, a stump and the trunk look like a tree. That's because a plane cut is changing only a 0 LOD. And let's open a stump, for example, and select LOD. On LOD 0 it looks normally. Here is LOD 0, and on LOD 1 it has an LOD of 3. Well, there are two ways to fix this in Unreal Engine. First, you can enable nanite support, so it will ignore any LODs. Second, you can disable LODs here, selecting custom and, for example, disable LOD 1, 2 and 3. or you can regenerate LOD automatically. And I will use the last one. I'm gonna regenerate LODs for this stump. So I'm gonna scroll down. Where is it? Here to LOD settings, and we have a number of LODs here. Now it is 4. I'm gonna set it to 0, apply changes. It has deleted me every LOD except 0. And next, okay, I have lost it again. I'm gonna select number of LODs, 6 for example, and apply changes. Also, I'm keeping selected a flag called autocompute LOD distance. So now my LODs looks like this. This is LOD 1, 4, and 5, and so on. So, but for trunk, I'm not gonna do that. I'm gonna use a nanites because I don't like how auto LOD works for leaves. Leaves are looking and thin meshes because auto LOD can just cut me part of this branch and part of a leaf. So I'm just gonna enable nanite support for this trunk and save it. Well, there is a lot of things that we have to do. Let's show simple collision for our trunk and stump. And as you can see, a collision here remains from a whole tree. So for trunk, I'm gonna just scale a capsule component a little bit and move it up like this and save it. That's all for trunk, and let's do almost the same for stump. For stump, we also have such collision, but here I'm gonna remove it and add a box simplified collision. Scale it to fit a stump size, like this maybe, and move it a little bit to the bottom. Save it. Well, now let's save all, and we can delete these meshes from a scene. We don't need them here anymore. Now let's open our BP3. Well, what we're gonna have here? We're gonna have two static meshes, and let's add them. Static mesh component, and let's call it stump. And let's duplicate it and call it trunk. And select the meshes. For stump, it's gonna be SM stump. As this one. And for trunk, it's gonna be SM trunk. Save compile. By default, we have to disable collision for them. So collision preset, let's make their collision preset custom and collision enabled set to no collision. For trunk, also custom and no collision. Also, we should make them invisible now. Invisible and disable visibility for both stump and trunk. Compile and save. Now let's open an event graph for our BP3. Now we have to call something. We have to do something when a tree is cutted. So let's add a custom event and call it onTreeCutted. And let's navigate back to event shop, and here after activating in Niagara, we're gonna check if get health, if health is less than or equal to 0. Also, I have already set it a health to 15, so it's 15, so I will need only one hit with an X to make it cut it. Compile and save, and if health is less than or equal to 0, we're gonna call this event onTreeCutted. So on true, we're gonna call onTreeCutted. Compile and save. Well, what should we do on treecutted? First, we're gonna get tree and make it invisible. So we're gonna set its visibility to false. Next, we're gonna get tree and set its collision to no collision. So set collision enabled, no collision. We should also disable collision for our tree cutting box. So let's get tree cutting box and plug it here. Compile and save. Well, now we have to make stump and trunk visible. So let's get stump, let's get trunk and set their visibility to true. Next, we're gonna enable collisions for them. So set collision enabled for stump and for trunk. Set collision enabled. Current physics. Also, one more thing that we have to do, we have to navigate to event chop, move everything a little bit to the right, and we're gonna check if health here. So let's get health if it is greater than 0. Well, if it is greater, then we should do what we are doing. Well, we have enabled a collision for stump and trunk, and the last thing that we have to do, I think that almost the last, let's get trunk and set simulates physics. Simulate. Well, and now if we start, a tree will be replaced. You may mention it, but I think that it will not fall. Here it is. It just moved a little bit to the bottom because collision is not precise, and it stays at the place. Well, what we have to do, we have to get trunk. First, let's select trunk static mesh here and set its mass. Let's make it 1500. Decrease an angular damping for a little, for example 0.5, linear damping to 0.05, and compile and save. And let's add an impulse. Well, and let's let it be, for example, 50 on X, and also add a velocity change. And play. And start. Well, now tree is falling. And I think that we can also finish at this place, but let me check a few more times. Well, that's how it works. Also, as you can see, a player can move a tree, and I think that's a normal behavior, by the way. But its rotation is too high. So let's what should we do? We can add a physics material here, by the way, but I don't remember what we have. Let's select a trunk. Let's select physics material override here, and create new physics material asset. And we can let's navigate to a folder here and select static mesh. Maybe we can create it from here. Well, not. Okay, right click on empty place and let's type in physics material. Not sure. Let me open it. Yes, that's it. So, and let's name it PM trunk. Here we can change some physics parameters and okay, what we're gonna do? Restitution density. Okay, well, we don't have something to a rotation here. Okay, so I think that we don't need it, by the way. Then we have to change something here. Well, can we lock? We should not lock rotation. I think that we should change an angular damping from 0.5 to some other value, but we should not change it immediately or it will fall too slowly. So maybe let's do it like this. Let's add a delay of 3 seconds, select trunk and set angular damping to something big enough, maybe 5. I'm not sure, it may affect a little a way it falls, but we will see now. Yeah, now it falls too slowly, and as you can see, it's much harder to rotate it. Okay, 5 is too big number, maybe 1. Also, maybe there is a way to limit somehow an angular speed, but to be honest, I don't know how to do it without checking it every time. Well, on 1 it seems to work fine. So that's it for this video. Now we can cut a tree and it falls, and I think that the next video will be final part on which our tree we will be able to replace this trunk with some logs that can be later collected with the player. Thanks for watching, hope it will help someone.